Welcome to Section 2. It is time to move from theory to practice. In this section, we are going to build your very first Arduino class from scratch. We will use a simple LED as our subject, which is the perfect way to understand the core building blocks of object-oriented programming. An LED might seem simple, but it has everything we need to learn OOP. It has properties like a pin number and a state, and it has behaviors like turning on, turning off, or blinking. By the end of this section, you will start thinking about digital right and start thinking about LED objects. We will follow a structured path, first defining the blueprint, adding their attributes, setting up the constructor, and finally creating methods to control the hardware. This modular approach is exactly how professional libraries are built. Instead of having variables scattered at the top of your sketch, all the logic for the LED will be contained within the class. This makes your main program incredibly clean and easy to manage, especially when we add more LEDs later on. Are you ready to write your first line of OOP code?
Let's go.
In the next lecture, 02.02, we will create the basic structure of our Led class. See you there. In this lecture, we are going to lay the foundation. We will create the basic shell, or the blueprint, of our Led class. In C++, which is the language Arduino uses, a class is defined using the class keyword followed by the name of the class. To define a class, we use the keyword class followed by the name, in our case, Led. By convention, class names start with an uppercase letter. We then open a pair of curly braces and, very importantly, we must end with a semicolon after the closing brace. Inside the class, we need to decide who can see our data and functions. We use access specifiers like public and private. For now, we will add the public keyword because we want our main program to be able to interact with the methods we'll create later. Think of this code as a blueprint for a house. It defines how the house should be built, but it is not the house itself. Right now, our class is empty, but it's the container that will hold all our LEDs, properties, and behaviors. Now that we have the shell, let's give it some characteristics. In the next lecture, 02.03, we will add attributes to the Led class. See you there. Now that we have our class structure, it's time to add attributes. Attributes are the data, or variables that belong to the class. For an LED, what information do we need to keep track of? Primarily, a digital pin it's connected to and its current state. We will add two variables. A byte named pin to store the hardware pin number, and a byte named state to remember if the LED is currently high or low. Note that we place these under the private access specifier because we want to protect this data from being changed directly by the main program. This is a core concept called encapsulation. By making these attributes private, we ensure that the state of our hardware remains consistent. The only way to change the LED state will be through the controlled methods we'll write later. In Arduino development, we use lowercase for simple attributes. Some developers like to add an underscore prefix to private variables, like underscore pin, to distinguish them from local variables. Choose a style that works for you and stay consistent. We have the data, but how do we initialize it? In the next lecture, 02.04, we will create the constructor, which is the function that runs when you create a new LED object. See you there. The constructor is a special function that is automatically called when you create an object. Its job is to initialize the attributes of the class. In our case, the constructor will take the pin number as an input and set up the hardware for us. A constructor must have the exact same name as the class, and it does not have a return type, not even void. We place it in the public section so it can be called when we create an instance of the LED. Here, we pass a byte name pin as an argument. Inside the constructor, we assign the incoming pin value to our private pin attribute using the this pointer to avoid confusion. Then, we do something very important. We call pin mode to set our pin as an output. Now, the object is ready to control the hardware the moment it is created. By putting the pin mode logic here, we ensure that every LED object we create is automatically configured correctly. We also set a default state of LOW to make sure the LED starts in the off position. Our LED class can now store data and initialize itself, but it still can't do anything. In the next lecture, 02.05, we will add methods to actually control the light. See you there. Methods are the functions that live inside a class. They define the behaviors of our object. For our Led class, we want to be able to turn the light on, turn it off, and maybe even toggle its state. Let's write the logic to make this happen. We will add two simple methods, on and off. Inside on, we set our state variable to high and call digital write using the pin attribute. The off method does the exact opposite. Notice how these methods are public, so they can be called from our main loop. A very useful behavior is toggle. Instead of checking if the LED is on or off ourselves, we let the object handle it. If the current state is high, we call off, otherwise we call on. This abstraction makes our main code much cleaner. By using these methods, we ensure that the internal state variable always matches the actual hardware. You no longer need to remember which pin is connected to which LED. In your main loop, you just tell the object what to do. Our blueprint is complete. Now, let's see it in action. In the next lecture, 02.06, we will instantiate an LED object and run it on a real Arduino. See you there. It is finally time to bring our code to life. We have the blueprint, but now we need to create an actual object from it. In this lecture, we will learn how to instantiate our Led class and use it to control a real LED in our Arduino program. To create an object, we use the class name followed by our chosen object name. Here, we create an LED object named myLED and pass the value 13 to the constructor. This tells the object it is connected to pin 13. We do this at the start of our script, outside any functions. Now, look how clean our loop becomes. We simply call my LED dart on, wait for 500 milliseconds, then call my LED dart OOP. We don't have to worry about the pin number, or the digital write command anymore. The object handles everything internally. The real magic happens when you need more components. You can create a red LED and a blue LED just by making new instances. Each one will manage its own pin and state independently, keeping your main sketch clean and professional. Congratulations on creating your first Arduino class. But having the class inside your main sketch can get messy. In the next section, Lecture 03.01, we'll learn how to organize our code by moving the class into separate files. See you there.